So thank you, Dr. Wu, for this dynamic and comprehensive talk. So although you have a high probability to get your flight late, so I still want to control the time. Okay. So the first question is, so this is a question from the audience. So comparing to 777X and the present 777, so what's the new innovation?
Yeah, so I think the 777X has a new composite wing structure. So it will be basically, it used to be a more aluminum structure, but it will be learning from the 787 lessons, it will be a composite wing structure. So, and there will be other new technologies like avionics and others as well. So ultimately, the goal is to reduce the weight, reduce the cost. So it's more efficient, more fuel efficient. So fuel efficiency is one of the key drivers in recent years, because fuel efficiency will lead to cost savings for airlines, but also reduce environmental footprint.
Okay. So all the commercial aircraft is 7X7. So now we are already at the 787. So is the next one we will call 797, or what's after this 797?
Well, that's not really a question that I can answer, but as far as I know, at the moment, we did not plan any 797. I know on the website, people are talking about this splendid wing aircraft as a 797. That's not the case. So I have shown later on up to 2020, we have a series of derivatives. In the recent years, it will be derivatives of like 777X, like 737 MAX, and that sort of it's currently open to the public. So yeah.
Okay, so you will basically keep the series and change the last letter.
Yeah, because we have just
U2 A B C D E R.
Yeah, because we have just done a 787, and it has been a very, very time-consuming exercise. So not easy to make a new aircraft program, totally brand new.
Okay, so as you know, 3D printing is a very popular manufacturing process now. Do you think there's some future for 3D printing for aerospace aircraft application, not for the development part? Development part we can understand 3D printing is important, but for the real aircraft.
Yeah, for 3D printing, I think some parts has been used in military aircraft already. So it's for commercial aircraft, the requirement is much more stringent. So I think the possibility will be more on secondary or no structural components to start with, but ultimately, even for no structural components, the reliability, consistency, reliability will be the key. So how can you produce the structure every time the same? So without pores, for instance, the 3D printing, if you can achieve that, and then it's possible. Yeah, I think part of for 3D printing, the other challenge is also how to develop a certification philosophy so you can actually certify the actual manufacturing process. But it's being worked on, and our company, both us and Airbus, are very interested in it. But at the moment, there is still limited application due to certification and other requirement.
Okay, I got a good information. Your flight already delayed for 45 minutes. Although the performance of Boeing is so that led us to have a little bit more time to discuss.
No, it's Airbus aircraft.
Okay. So, Dr. Wu, can you talk about the self-healing material? So, is it a new material possible for future aircraft self-healing structure or self-healing material concept?
I think it's an interesting concept because even myself, I work in polymer, so I have written a self-healing polymeric material review back in 2006, I think. So I was at the time I wasn't working for Boeing, I was working for CSIRO, the Australian Government Research Organization, but I was doing Boeing projects. So I was always thinking whether, so I wrote the review because I want to know what is the current status of the technology in order to assess the feasibility. I think there are possibilities, but the current technology, due to one way or another, there are still significant limitation for actual use, because the self-healing material, you need to ensure the healing is happening every single time when it's needed. So the current system, I cannot see that level of robustness and reliability yet. So going forward with further development, maybe, but the current one, I still can see the limitation. So it's not just once or twice. So it actually needs to be done, because aircraft's life is 30 years. So while you might say I can change it during the process, but still it needs to be reliable. So.
Okay. So which model of a Boeing company you prefer, model of aircraft?
Which model?
Yeah. Which aircraft do you prefer?
I think I like all the models, but because they are for different purpose. But 787 certainly is very comfortable because the cabin humidity is high, but 777 is one of the most liked aircraft by airlines. But 737 is the most popular aircraft. Okay. Currently, so.
Okay, I thought you will answer the next one you prefer. Okay, so so as you know, you have two competitors, ABC, okay, Airbus, yeah, and the Chinese Comac. So how do you think the competition of these two potential, one competitor and one potential competitor will affect your Chinese market evolution?
I always think, yes, of course, but I always think instead of worry about the competitor, you need to keep an eye, but most importantly, you need to keep moving. You need to keep innovating. You need to go faster than your competitor instead of worry about it. Yeah, that's how I see. I think it's a good thing because otherwise we become too complacent.
Okay. So, so do you have some advice to our young students? Because many people in the audience are PhD students. So you start with basic research and now you switch progressively to applied research. So do you have any advice for basic research and applied research and how to select your own way to develop your career?
I think it depends on individual. So I don't think I have one formula for choosing one's career because each person's capability, their interest will be different. So from my own personal point of view, as Professor Liu said, I did start with research and then move into industry. So one lesson learned is that when I do research, I thought I understand what the products need, what the products and market needs are, and it turned out to be wrong. So I think because in order for, it depends. So some people, they just want to do fundamental research, which is fine. It's also very respectable because that will help to advance the human knowledge. But if you do want to develop a product, then it will be best. Going forward, it's more and more important for teamwork, cross-disciplinary, cross-company. It will be critical for us to achieve something useful. That is a very important thing. So you always need to know what you know the best. But in order to achieve this goal, you probably need to also team up with someone else who know other components best. And together, you achieve something synergistic.
Okay. So last two questions. Okay, one is related to the future aircraft. So as you know, Airbus launch a new, concept aircraft, electrical aircraft. So do you think there is any future for this kind of aircraft?
Not in the near future, but with the tech. But you never say never. So we never can predict internet or a lot of things nowadays. So with the technology, well, for commercial, I think those electrical aircraft can start with unmanned vehicles and other shorter-term applications to test out the technology evolution. But in the near future, from what we can see now, liquid fuel is still the source for commercial aircraft, because you really need the reliability. You cannot just stop in the middle of the air. So I think that is, but however, you never say never.
Yeah, as you know, we have no new model of solar energy aircraft. So although it's some people say it's a joke, and some people say it's a good thing for the concept aircraft. So what's your opinion on this?
The solar energy aircraft is not, it's not new, because one of our international center in Madrid, our Boeing Research and Technology Europe, has already made those prototype of solar-powered unmanned vehicles. Yeah. So that is not, but real commercial people carrying aircraft is a different story than those unmanned vehicles. So I think it's certainly worthwhile to explore and continuously explore and improve. But in the near future, probably liquid fuel is still the only viable fuel.
Okay. So thank you, Dr. Wu, for this sharing session. Thank you very much for your talk.
Thank you. Thank you.
Thank you, Dr. Wu and Professor Lu. Would you please remain on the stage? We will now invite the President to come up to the stage to present souvenirs to our distinguished speakers and Dr. Chow on behalf of CTU. President, please. May I now invite President Wei Kuo to present souvenir to Dr. Wu Dongyang. May I now invite Colonel Johnny Shen to come on stage. May I now invite President Wei Kuo to present a souvenir to Colonel Johnny Shen.
So this is a Crystal U-2 aircraft, so I hope Colonel Shen can recognize his aircraft.
Thank you, President. May I now invite Dr. Zhao Ching to come up to the stage. To show our appreciation to Dr. Zhao Ching's continuous support to CTU and to our graduate school, may I now invite President Wei Kuo to present to Dr. Chow a specially made photo album which has recorded all the lovely moments that Dr. Chow spent with CTU. Before the ceremony ends, Professor Jan Liu will deliver words of thanks to us. Professor, please.
Thank you, Dr. Zhou, Dr. Wu, and Colonel Shen. So we hope you have enjoyed today's lectures. And on behalf of CTU, I would like to express our sincere gratitude to both Colonel Shen and Dr. Wu Dongyang for giving such interesting lectures today. My special thanks to Dr. Zhou, since the success of today's events was only possible through his great support. And last but not least, thank you very much for all your participation in today's lecture. And also, I would like to invite you to enjoy the tea reception. Thank you.
Now it comes to the end of the lectures.